Hello, networking nerds. I am studying for my CCNP Encore. Right now, I am on switching. Layer 2. I do not like Layer 2. I specifically do not like spanning tree. It is confusing to me. So I am labbing. Yay! What is Layer 2 frame? What is this dude talking about? There's something called the OSI model. There are 7 layers. It's this abstraction concept that kind of helps you understand how information can get from an end host like a PC through a stack and communicated through a network. Layer 1 is physical. Copper cables, fiber optics, wireless things. Layer 2 are frames, datagram frames, right? Is that what it's called? I don't know. Layer 2 are frames. Frames are meant to reside on a local area network, something that is all in the same subnet. Think about you're at home and you send a cat picture to your roommate in the same home network. It's not going to leave your house and go out to the wide area network or the internet in your case. It's going to stay in the local area network, and that will be a layer 2 frame that is in the LAN, in the local area network. It's just going to go from here to here. MAC addresses are used. Layer 2 addresses are called MAC addresses, media access control. There are these numbers that are burnt in addresses into the NICs, network interface cards of whatever device you are on, and they all have numbers associated with them, and switches at layer 2 learn those MAC addresses. They maintain a MAC address table, source and destination MAC addresses, so that when a frame comes into the switch and it's destined for MAC address ABCD, it can look and say, have I learned ABCD? Yes, it came in this port. Let me send it out that port. Yay! That reduces the collision domain, broadcast domain. It reduces the collision domain because it only comes in one port, out another port, as opposed to a hub that goes out everywhere and everything's a collision. Yes, I think I have that right. Anyway, spanning tree protocol. What is spanning tree protocol? At layer 2, there is nothing in the layer 2 frame that can stop this thing called a frame from just traversing the local area network forever. At the next layer of the OSI model, layer 3, there are IP packets. They have something in them called a TTL, or a time to live value. It starts at, I forget what it is, 255, something like that. But every router that it goes through, which are layer 3 devices that are networks to each other, not LANs, but other networks, the TTL is decremented. And when it gets down to 0, the packet gets dropped by that receiving router. Frames don't have a time to live. They will live forever. That is a problem because in a layer 2 environment, if you have 2 cables connecting 2 switches, it's a terrible looking loop, but that is a loop. Those things can go forever. The frames will live forever. It will take up resources. It will make your CPU go crazy, and it can crash a switch and completely bring it to its knees. I've seen that. It's not fun, especially in production. So I'm going to show you a lab in CML. CML. That is not the lab. Wait, maybe it is. Okay, so we are going to drag this around here. I'm going to add 2 switches just to show you what I'm doing. I like to use labbing to reinforce concepts, and right now I am struggling with spanning tree. Again, it's that protocol that stops these layer 2 loops. Generally, a king of the layer 2 domain called a root bridge is elected. There is something called a bridge ID, which is a priority, plus the VLAN, and then it's MAC address of that switch. It creates a bridge ID, and the lowest value bridge ID will be elected the king of the layer 2 switching domain. And then for those redundant links that created that loop, certain links will go through a process. They send information to each other called BPDUs, Bridging Protocol Data Units, I believe the acronym stands for. And those BPDUs have all kinds of information like the bridge ID of where they came from and the interface cost and priority and all kinds of other stuff that I'm not going to get into here, but there's information exchanged. They all agree who is the king. They all agree what ports should forward traffic and what ports should be blocked. So in order to mitigate that loop that could crush the network. Well, I am going to pick MIA, IOL L2. This is CML, Cisco Modeling Labs. 1, 2, great. All right, I'm going to click this to center. I'm going to make it a little bigger so we can see what we're doing. I don't know why these look like this. All right, I know there's other ways to do this, but let's just start this guy. Once they're green and running, we can add links. So there's one link there, E0 to E0 create. There is no loop here. This is just a point-to-point link. A frame cannot go, there's one path, right? There's no loop. Look for the circle. There's no circle yet, or rectangle, for lack of a better term. But if we create another link, a redundant link, because you usually want redundant links between devices in case one of the cables or optics or ports fail, you have redundancy to help build some resiliency. Now, you may notice something that resembles a circle or an ellipse or a way that a frame that does not have an ability to stop it from traversing forever can come across this link, back here, pew, 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 forever and ever and ever. That can be a problem. So let's look at the spanning tree. I'm going to right click switch 1 and click console. So I want to put a host name on this device because it drives me crazy that it doesn't have a host name. So enable, boop, gets you to the pound, is it config mode? I forget all the modes. It's been a while since CCNA. Config T is how you make a configuration change. And we're going to say host name. That is not how you spell host name. Host name SW1. Entrez-vous, s'il vous plaît. Exit, right. All right, so now, as you can see, our name changed from insert host name here to switch 1. This is just, you can call it my OCD or whatever you want, but I must have a proper host name. All right, now we are in switch 2. As you can see, insert host name here again, down here. So we're gonna do enable. We're gonna do config T, and we're gonna say host name SW2. We're gonna go back, exit, write the change. All right, so now we got switch 1 and switch 2. Yay! One thing I want to do is look for the MAC address on switch 1 because the MAC address is going to be used by Spanning Tree Protocol in the bridge ID, which is going to be communicated with BPDUs, bridging protocol data units, to communicate with each other to elect the king. The king will have all their ports in a forwarding state called designated ports. Oh. One thing that you can do is show spanning tree. I'm just going to do a show span tab. There's an autocomplete, which is super helpful in Cisco iOS. Hit enter. What we see here, my friends, ABC00100. All right, well, this is the MAC address I was looking for. I forget how to find a MAC address in a virtual device. But in any case, it is right here. So what you'll see here is this bridge is the root. Switch 1 is the root bridge. The root is the king. The king or queen will have all their ports in designated, a designated role and in forwarding. So what we're looking at here is the priority. The default priority for spanning tree is 32.768 plus, I believe, the value of the VLAN. I have not configured any VLAN, so we're just dealing with VLAN 1, which is a default. So 32.768 plus 1 is 32.769. Here's the MAC address. And if we go into switch 2 and look at show spanning tree, it should show the bridge ID of switch 1, which I believe is the priority plus the MAC address. So let's go over to switch 2 and do a show spanning tree. All right, so this is going to show us the root, which ABC00100. We're in switch 2, which is not the root bridge. This is the MAC address of the root bridge, ends in 0100, which we saw over here. This bridge is the root. We are in here. This is my MAC address. In switch 2, we see that the root bridge is here. That is the MAC address. The port that is going to forward traffic to the root bridge is Ethernet 00. And our bridge ID for our local switch ends in 0200. So MAC of switch 2 is 0200, MAC of switch 1 is 0100. Yay! Another difference we can see in switch 2, which is not the root bridge, is we're going to have a blocked port. Ignore Ethernet 2 and 3. That's just kind of a bug slash feature in virtualized switches. These don't actually exist. They're not up. Pretend they're not there. What we're interested in is these two here. So Ethernet 0, 0. Switch on the left, switch 1 is the root bridge. Switch on the right, switch 2 is not a root bridge. And Ethernet 0, 0 is the root port. What is the root port? Well, it's in a forwarding state right here. And that is the port that is forwarding traffic over to the root bridge. In this little circle guy that you can see here, we have to block a port, because if we don't block a port, we have a loop. Think of the circle or weird ellipse. Spanning tree, after doing a bunch of magic and BPDUs and looking back and forth and exchanging all this information and doing some calculations, it is determined that Ethernet 0, 0 on switch 2 is the root port, which is directed back to the root bridge to send and receive traffic over there. Ethernet 0, 1 is going to be the alternate port role, also in a blocking state. So this, in traditional spanning tree, this is lost bandwidth. This link is not going to be used. It's really just going to use up here until that fails, and then it'll use down the bottom. There will be a spanning tree recalculation if this were to fail, which I guess we could do. So let's shut down Ethernet 0, 0 on switch 1. Show you down here. So I'm going to simulate a failure on switch 1. Interface ETH 0, 0 shut. Do show interface. There we go. So it just went down. Do show interface ETH 0, 0. And what we're looking for here, admin down. So it is down, line protocol is down, and we also got a couple of console messages here that it is down. Why did I shut that down? Well, because what I wanted to show you is Ethernet 0, 0 between the switches was the link that was forwarding traffic. Ethernet 0 was the root port, and Ethernet 0, 1 was an alternate port in a blocking state. So now that we've shut down the top link, what I would expect is to see Ethernet 0, 1 on switch 2 transition from an alternate port to a root port. So let's take a look at that. So as we can see, we're now on switch 2, and like we said, Ethernet 0, 1 was in a blocking state as an alternate port. So now if we do a show spanning tree again, we should see that spanning tree now allows traffic to go across Ethernet 0, 1 because Ethernet 0, 0's facing port went down on switch 1, and that is a dead place. You don't want to send anything there. So let's do a show spanning tree here. All right, so pretty cool. So as you can see, I think you can see, where Ethernet 0, 1 on switch 2 was in a blocking state and an alternate port, meaning a valid backup. Once we killed Ethernet 0, 0 on switch 1 on the other side, now Ethernet 0, 1 became the root port and is forwarding traffic. Ethernet 0, 0 is a designated port. Surprised it's not in blocking. Still shows, let's check over here on switch 1. We'll see, and show spanning tree. So ETH 0, 0 is now gone, designated, and ETH 0, 0 is the root port here. So again, this might be a weird little buggy slash feature thing in virtual switching. I don't love doing switching in virtualized environments. I have physical switches. I just didn't feel like going and firing them up. I believe what should have happened here on Ethernet 0 is this should not be in a forwarding state because the other side is down. Ethernet 0, 0 is down. So that just might be a weird little buggy feature in here. But that is the quickest explanation I could give to what's happening in my studies. Layer 2, spanning tree protocol to prevent layer 2 loops. We talked about what a frame is at layer 2. We mentioned the OSI model, a fun little, not an acronym, A fun little memory technique for remembering the 7 layers of the OSI model is please do not throw sausage pizza away. But we were talking about layer 2 of the OSI model, which is above the physical layer and below the network layer. Talking about layer 2 MAC addresses, which are held in the MAC address table. MAC addresses are typically for LAN connectivity from host to host, talking to a LAN, and it uses source and destination MAC addresses to make those forwarding decisions. And because layer 2 frames do not have a TTL like layer 3 IP packets do, we need a way to block loops so that those frames don't go forever and ever and crush our switch CPUs and eventually our switches if enough traffic is sent over that link or those links. So Spanning Tree Protocol was created by Radia Perlman to, I guess, turn redundant links off temporarily, put them in a blocking state to kill the loop. But when the primary link goes down and that redundant path is needed, Spanning Tree does a recalculation, brings it back up, and gets it working, which is what we saw here. So that is it. CCNP studies continue. I am hoping to get out of Spanning Tree today and get into IP routing, which I think is chapter 6 of the OCG book, which will be followed by EIGRP, chapter 7. And my CCNP study group in It's All About the Journey Discord server will meet on Monday in a few days to go over those 2 chapters. So if you're studying for your CCNP, hop on in our Discord. You can find our study group if you go to linktree/Art of NetEng, I think. Let me find it. Link. Here it is. I wonder if I can show this. Split screen. There we go. So if you go to linktree/Art of NetEng, you'll see a bunch of links. And if you go down to join It's All About the Journey Discord server, you can hop in there, join the Discord server. And if you're studying for your CCNA, there's a CCNA room, which had a study group occurring last night. I saw happening. Great job, everybody. And we have a CCNP study group in the CCNP Encore room that you can also join. It is free. We are just people trying to help each other, keep each other accountable. Some people are better at technologies than others. I'm not great at layer 2, so folks are helping me in there. I'm much more comfortable in layer 3, so I'm hoping to help folks that might not be as comfortable in layer 3 as I am in that study group. And we're going to kick some butt and pass this exam and get our CCNP. So that is it. That is the update. Thanks for watching. I'll see you next time.